Hydrostatics 2014, Part B of question 9. A cube of side X contains water to a height 18 centimeters. A solid body of weight 120 newtons, which looks like a set of headphones, is placed in the cube. It floats and the water level rises to 24 centimeters. The body is then completely submerged and tied to the bottom of the cube, which is diagram 3. Diagram 1 wasn't given, diagram 2 and 3 were. The water level rises to 32 centimeters. Find the value of X, find the tension in the string, and find the density of the body. Okay, so the weight, we know buoyancy is equal to weight, so the weight of the water displaced is 120. So what has happened between the first one and the second one? It's gone from 18 to 24. So it's gone up 6 centimeters. So the volume of this cube is going to be X multiplied by X multiplied by X. But because it's in centimeters, let's call it X over 100 by X over 100 by 0.06. That's the change in volume. So the buoyancy is equal to, it's in water, so the buoyancy's change is 1000 by X squared, 1000 by 0.06 X squared over 10,000 by G, and that's equal to the weight, which is 120. Okay, well, let's multiply this out. I've got 1, 2, 3, 1, 2, 3. So we'll leave the X squared there. So we're going to multiply 120 by 10. We'll write out the sum like this: 120 by 10, and then we're going to divide by 9.8 for G by 0.06. So that would give us 2040.82. 2040.82. So X is the square root of that number. X is equal to the square root of 2040.82. And the square root of 2040.82 is 45.2 centimeters. Okay, that's part 1. In part 2, we're asked for the tension in the string. So there's tension here. So we have two things going on. We have the tension in the string, and we have the weight. So, and we have the buoyancy going up. So we need to resolve these forces. So let's have a look at that. What's the difference in height? It's gone from 18 to 32. So that's a 14 centimeter increase. So let's have a look at that. So we're saying that the buoyancy is equal to the tension plus the weight, which we know is 120. So the change in buoyancy is going to be, well, let's have a look again. It's going to be 1000 by that X over 100, and we know X now at this point, and we know X squared. We have X squared up here, don't we? So we can use that, and that's going to be by the 0.14 by G, and that's going to be equal to tension plus 120. So 1000 by 2040.82 over 10,000 by 0.14 by 9.8 is equal to tension plus 120. Simplify this down and put it into our calculators. 3 and 3 zeros. Okay, so that we'll leave it like that. So we're going to be looking, typing into our calculator, 2040.82 times 0.14 times 9.8 divided by 10, which gives me a nice even number of 280.000504. So 280 will be fine. So, and what do we have with 280 equals tension plus 120. So tension, you can see there, is going to be 160 newtons. And in part 3, what did they ask us? Find the density of the body. Okay, let's look at finding the density. Okay, the density of the body in part 3 of the question. Rho Vg, buoyancy is going to be equal to the 120. So the density by the volume, which we have x, and we have how much it's risen by. So it's risen by, well, let's just double check that. How much is it risen by from beginning to end? It's gone from 18 up to 32. So it's risen by 14 when fully submerged. So my x was 45.2 centimeters. 45.2 centimeters by 45.2 centimeters by 14 centimeters is the volume that it has gone up when it's fully immersed. So that would be equal to 120. And if we type these three guys by 9.8 into our calculator, we're going to get 0.28 is equal to 120. So the density is 120 divided by 0.28, which gives us 428.6. 428.6.